In 1958, NTN began a study to develop an ultra-high-speed bearing for the Dream Train, which would connect Tokyo and Osaka, a distance of 550 kilometers, in only 3 hours. Six years later, in 1964, the Zero Series, the first high-speed train in the world, started the Tokyo-Osaka service at the speed of 210 kilometers per hour. Today and every day, Shinkansen trains make the equivalent of 10 round-the-world trips and transport more than 200,000 people. They have been operating for over 40 years without a single fatal accident. We would like to introduce the very sophisticated NTN railroad bearing technology, which has supported the long history of safe operation unique to Japan. This is the bogie, which tracks the Shinkansen train at speeds over 300 kilometers per hour. The bogie consists of the traction motor, reduction gear unit, axle and wheels. To start with, let's look at NTN's journal bearing technology. Journal bearings support heavy loads and must be the most reliable bearings on the Shinkansen train. This is the 500 series, which operates between Tokyo and Hakata at a speed of 300 kilometers per hour over the 1,200 kilometer run. NTN journal bearings are also installed in this world-class high-speed train. NTN conducted a grease behavior test to examine grease lubrication characteristics inside journal bearings for the Shinkansen. As a result, we developed grease seal technology that performs well across a wide range of speeds. NTN also carried out on-board analyses of the prototype train during the research and development stages. NTN measured the bearing temperatures and vibration accelerations up to speeds of 350 kilometers per hour, and this played a vital role in the development process of the 500 series. Furthermore, NTN developed the journal bearing test machine, with which we can conduct tests up to speeds equivalent to 500 kilometers per hour, with the same vibrations as an actual train. This equipment helped NTN develop journal bearings that can withstand a speed of 400 kilometers per hour. We are also working on the development of a malfunction detecting system, which senses abnormal temperature or vibration of journal bearings in order to further improve journal bearing reliability. Currently, NTN journal bearings are used in the entire Shinkansen fleet, which holds the world record for top speed and maintains the world's safest operating record. It is the reliability of NTN journal bearings that make this possible. Next, we will introduce NTN traction motor bearings. The traction motor produces the huge power needed to rotate the wheels and operates under high speed and high temperature conditions. Sometimes the bearings are damaged through electrical corrosion. NTN has introduced new test machines which simulate the actual operating conditions of a traction motor. Through these tests, NTN is making a continuous effort to develop durable, high-speed, high-temperature bearings. Additionally, NTN has developed the Mega Ohm series, which prevents electrical corrosion on the rolling surfaces by insulating the bearings from electric currents. In the development of the mega-ohm insulated bearings, NTN assumed the most severe operating conditions and designed bearings to meet these worst-case scenarios. NTN conducted voltage resistance and heat cycle tests to ensure the insulating layer would function in the harshest of applications. Field experience has confirmed that our bearings have superior insulating performance even when used in the most severe environments. Today, NTN Mega-Ohm series are installed on many of the traction motors found throughout Japan. Finally, let's look at NTN reduction gear unit bearings. The bearings in the reduction gear unit must be free from seizure due to poor lubrication in extremely cold weather and cage deformation due to excessive acceleration transferred through the axle from the wheels. The stresses on the cage are analyzed by the finite element method, and the cage strength must always be maximized in every case. Furthermore, the cage is tested on the accelerative vibration test machine and the actual stresses are measured, or the falling impact test machine to confirm the strength of the cage. The reduction gear unit is located in a refrigerator and the bearings are tested at below -40 degrees centigrade to evaluate performance under extremely low temperatures. NTN's ultra-high-speed bearing technology for journal bearings, traction motor bearings and reduction gear unit bearings has been supporting the safe operation of Shinkansen trains in Japan for more than 40 years. This superior technology and reliability are used not only in Japanese high-speed trains, but also the world's high-speed trains, contributing to the improvement of safety worldwide. Recently, NTN's advanced technology has been adapted to new streetcars, also known as light rail vehicles, which are being revived throughout the world due to environmental considerations. Also, NTN bearings are widely used in a variety of local line trains. Furthermore, the gauge change train, which can run on various gauges and is also a high-speed train, will be introduced soon, supported by NTN railroad bearing technology. We at NTN, as a manufacturer of railroad bearings, will support the technology and safety of high-speed trains in Japan and around the world.